Here we go for the second part of our convolutional neural network with handwritten digit classification. Here we have a Python file which is the model before we switch to Android Studio. There are two versions. The first one is Keras version and the second one is TensorFlow version. And in this project we are interested in Keras version, since Keras is an open source neural network library written in Python, designed to enable fast experimentation with deep neural networks. By the way, we import the first part here, Keras, and the second one we also import TensorFlow, and we try to build a convolutional neural network. Let's have a look at a couple of functions here. The first one is load data function. This function is a standard reshaping function, and we try to vectorize the input data. What we mean by vectorizing is the input image, which is drawn by the user who is interacting with the application. We take the raw image and we from the user, and we convert it to TensorFlow map in order to fit it in our model. So that's what our load data function is doing. It takes an image of 28 by 28 pixels, and we convert it to a TensorFlow and feed it into our model. Then after we have to, since we're dealing with a 4-dimensional tensor, so we take the length, the width, size, and depth, and generally the depth is 1 as it's a single ray image. And after we reshape it by using NumPy reshape function, and after vectorizing we have to split it to training sets and test sets. That's it, and we have the return value. That's it for the load data function, which is the first function here we defined in our Python file. And we'll like go a bit faster. The second one is build model, which, as the name implies, the goal of this function is to build our model by using a sequential model. But you can see that we have 3 convolutional blocks. The first block is we do the convolutional by taking the MNIST, which is the actual digit, to detect what the filtered image is exactly. And the second one we do max pooling. In fact, pooling layers reduce the dimensions of the data by combining the outputs of neurons clusters at one layer into a single neuron in the next layer. So we keep doing the same process until we are at the end. We got now a 4 by 4 by 256 dimension tensor, and we flatten that. We flatten the tensor into 1-dimensional array. So as we need a set of probability value, prediction value, so we add 2 connected layers, dense layer. So, and after that we return the model. how about the third function is called train, as the name implies. Here we train our model. We define two main things. The first one is the loss function. We need to minimize the loss, and we define an optimizer to if an optimizer is a kind of is a form of gradient descent, so we define it, and after we have to fit the model. So the function fit is a way to train the model. So by defining the batch size, epochs, and validation data, of course. And we move to the next one is export model. After building what is first, after loading the data, building the model, training our model, and we have now to export. We have to write a graph and save that graph. We freeze it. What we mean here is by saving the weight somewhere, and we print our graph. Since we have to export this training model, we have to export it in a PBF file so that we can use it later, for example on a server or on Android platform or iOS. So, and at the end we define the last function, which is the main function, in order to export our model. We export the model and we save it. That's it for the Python file. So we can open quickly the second one, which is Android. We exported our model to Android Studio, and this time we're gonna have a look at a portion of codes, and after that we're gonna run our model on a true device, Android mobile device, and then gonna see how our model is working. Okay, so we gonna first deal with the main activity, which is here, written in Java, right? So we have the main activity as written in Java, but before this one we're gonna show you the XML file that the user interact with. It contains 4 components. The first view is where the user is supposed to draw a handwritten digit, and we have a button here, clear, where it's gonna clear, and to reset the view empty. And after this we also have the detect button. The detect button performs a task in the backend. When the user clicks here, then it takes the image as input and send it to the TensorFlow model and return an output, and the output is gonna be here. Oh, come on, let me zoom out. The output is gonna be here. So we have the view, the first one, where the user draws a cipher. So here is when the user wants to reset, and we have detect, where the user is supposed to, when it clicks, then the model is going to predict, and the result will be shown over here, the last text view. That's it for the interface that the user is supposed to interact with. Then we have the main activity, which is written in Java. The first thing we do is we import a lot of components like text view, array list, motion event, button, and on creation here we declare some variables, and on create method we reference, for example, the draw view, which is written in XML file, and button, clear button, and also detect button. Once we're done with it, so we go to the load model, which normally add two classifiers to our classifier array list. We have here the TensorFlow classifier and the Keras classifier. That's it. And on click of the button, depending either clear button or detect button, if it's clear, we reset, and we reset our draw view and we put it back empty. But if the user clicks on detect button, then in this case we get the pixel data and store it in an array. So that's it. And we can have a look on touch. This one, just we get the action and store it as an int. If we touch, or if the draw view is touched, then we begin to draw a line. We draw a line over here. If a finger is lifted or stop drawing, then in that case we also stop the process. So we call this method called process touch up. And we also have process touch down here, just to calculate the x and y coordinate where the user has touched. And at the end we have the process touch move. So that's it, and it's finished. We're gonna see how our model is working on a true mobile device, Android of course. Thank you guys.